Have you ever wondered how scientists managed to organize more than 100 elements into one simple table? Exploding head. And why do some elements behave similarly, even though they look completely different? Today, we're going to explore the periodic classification of elements, from its history to modern concepts, in a simple and powerful way. Let's start with a simple idea. In daily life, we classify things all the time. Clothes, right-pointing arrow, casual, formal. Food, right-pointing arrow, fruits, vegetables. Books, right-pointing arrow, fiction, academic. Similarly in chemistry, elements are grouped based on similar properties. Right-finger metals are grouped together because they conduct electricity. Right-finger non-metals are grouped together because they don't. So classification helps us study and understand elements easily. Now the big question: how did we reach the modern periodic table? Let's look at some important scientists' downfinger, small diamond Dobereiner's triads. He grouped elements in sets of 3. The middle element's mass was roughly the average of the other two. Crossmark problem. Only worked for a few elements. Not a complete system. Small diamond Newland's law of octaves. He said every eighth element has similar properties. Musical note, right finger like music octaves. Formula idea. If element is at position in, similar one is at n+7. Crossmark limitations. Worked only till calcium. No space for new elements. Wrong grouping sometimes. Small diamond Mendeleev's contribution star. This was a breakthrough. He arranged elements based on atomic mass and properties. Checkmark left gaps for undiscovered elements. Checkmark predicted their properties accurately. Checkmark even corrected wrong atomic masses. Right finger example. He placed iodine after tellurium despite mass difference. This became the foundation of modern periodic table. Small diamond Henry Moseley, most important, rocket. He changed everything. He said, right finger elements should be arranged by atomic number, not atomic mass. Pushpin modern periodic law. Properties of elements are periodic functions of their atomic numbers. Checkmark. This fixed all major problems. Checkmark gave us the modern periodic table. Now let's understand the structure. Bar graph 7 periods, rows, bar graph 18 groups, columns, large diamond blocks based on electronic configuration. S block right-pointing arrow groups 1 to 2, P block right-pointing arrow groups 13 to 18, D block right-pointing arrow transition elements, F block right-pointing arrow lanthanides and actinides right finger. This arrangement helps us understand element behavior easily. What is periodicity? Right finger. It means repetition of properties at regular intervals. Let's look at key periodic trends. Down finger, small diamond atomic radius. Size of atom. Down arrow decreases across period. Up arrow increases down group. Small diamond ionic radius. Cation's right-pointing arrow smaller. Anion's right-pointing arrow larger. Up arrow down group. Down arrow across period. Small diamond ionization energy. Energy needed to remove electron. Up arrow across period. Down arrow down group. Small diamond electronegativity. Ability to attract electrons. Up arrow across period. Down arrow down group. Right finger fluorine is highest. Small diamond electron affinity. Energy released when atom gains electron. Up arrow across period. Down arrow down group. Electronic configuration tells us how electrons are arranged. Right finger formula. Maximum electrons in a shell equals 2n squared. This helps explain blocks of periodic table. Exploding head. Fun fact. Ever wondered why blocks are called S, P, D, F and not A, B, C? Right finger. It comes from quantum mechanics and orbital naming. So today we learned. Checkmark how elements are classified. Checkmark history of periodic table. Checkmark modern periodic law. Checkmark periodic trends. The periodic table is not just a chart.